There is a ball in a maze with empty spaces represented as 0 and walls represented as 1. The ball can go through empty spaces by rolling up, down, left, or right, but it won't stop rolling until it hitting a wall. When the ball stops, it could choose the next direction. Given the m times n maze, uh, the ball start and position and the destination, where start is equals to start row and start column, and destination is equals to destination row and destination column. Return true if the ball can stop at the destination, otherwise return false. You may assume the borders of the maze are all walls. See example, so we can see that these are all walls. The borders, borders are all walls here too. So in this example, we have true. One possible way is to move left, down, left, uh, left, down, left, down, right, down, right. So there's no way for the ball to stop. Just notice that you can pass through but you cannot stop there. So we can't stop here, but we can pass it. So the ball has to hit a wall for it to stop and then choose the direction. Okay, so this is uh breadth first search cover. Will solve this with PFS. So let's make what do we need for this problem? Let's make our maze. Let's make our m and n to be equals to the length of maze. Create the dimensions. Maze for our row and our column will be length of maze 0 at index 0. So now, what else do we need? We need to keep track of which have been visited. So visited, visited equals to let's make it a set. So now let's make our. So we need a queue too. DQ. And then put start inside. So this is the start position. So now let's make visited. Then add so let's add start to our visited. So so we need to add a tuple into tuple start. This is our start tuple, and so now let's make this. So while we have our key, let's go ahead and pop it off. So cur row and cur equals to q dot pop left. So now let's see if we are in the destination. So if cur row cur call destination return true. And so if we got to, I'll make our directions. So let's call it directions equals to 1 0 0 1 negative 1 0. So negative 1. So for dr, dc, and directions, let's make nc to be equals to nr for our new row and new car, and car will be equals to cur row and cur and cur call. I was thinking about what to do next. So we have to keep rolling until we hit a wall. So that will be, next one will be while. Keep rolling, rolling until we hit a wall. So while 0, so less than equals to nr plus dr less than m, and 0, it's the same concept also here. So less than equal nc plus dc less than n, and while our maze and our maze and our plus and our plus dr and nc plus dc is equals to, remember, 0, there's empty space 0. So while we have 0 and we're within bounds, let's keep bouncing. So that's basically it. So that would be 0. So nr plus equals to, let's add dr to it, and nr will be equals to where nc will be equals to dc. And that's basically, and that's technically it. So now let's check if nr and DC are in our set. So n if nr dc or nc in visited. So if they have been visited, not in visited, not in visited. Q dot append nr nc nc, and then let's make them visitor. So visitor will be visitor at n or nc, and that's basically, hold on, forgot to make this turbo. Return to false, otherwise it's false. So let's see if we have everything that we need. So there seems to be, but there might be a syntax. Oh, it's been accepted. Let me see. Let me test it again. Whoa, it's been accepted without any syntax errors. And that's it for this problem. So our time and space complexities are O of m times n for both time and space complexity. Time and space complexity are O of m times n. And let's submit to see if it's going to pass all cases. And it's been able to pass all cases. And that's it for this problem.